At the end of this video, you should be able to use a periodic table to name elements given their symbols, use a periodic table to write the symbols of elements given their names, describe the arrangement of the periodic table, and list the characteristics that distinguish metals, nonmetals, and metalloids. Chapter 1, Section 3, Elements. As you have read, elements are pure substances that cannot be decomposed by chemical changes. The elements serve as the building blocks of matter. Each element has characteristic properties. The elements are organized into groups based on similar chemical properties. This organization of elements is the periodic table, which is shown on the screen here. Each small square of the periodic table shows the name of one element and the letter symbol of the element. For example, the first square at the upper left represents element 1, hydrogen, which has the atomic symbol capital H. As you look through the table, you will see many familiar elements, including iron, sodium, neon, silver, copper, aluminum, sulfur, and lead. You can often relate the symbols to the English names of the elements, though some symbols are derived from the element's older name, which is often in Latin. Wolfram comes from the German name for tungsten. The table on the screen here lists some of those elements. Familiarize yourself with these elements and their symbols because they are commonly used throughout this course.
All elements are organized by their properties on the periodic table. All elements are denoted by 1, 2, or 3-letter symbols. The first letter of the symbol is always capitalized.
The vertical columns of the periodic table are called groups or families. Notice that they are numbered from 1 to 18 from left to right. Each group contains elements with similar chemical properties. For example, the elements in group 2 are beryllium, magnesium, calcium, strontium, barium, and radium. All of these elements are reactive metals with similar abilities to bond to other kinds of atoms. The two major categories of elements are metals and nonmetals. Metalloids have properties intermediate between those of metals and nonmetals. The horizontal rows of elements in the periodic table are called periods. Physical and chemical properties change somewhat regularly across a period. Elements that are close to each other in the same period tend to be more similar than elements that are farther apart. For example, in period 2, the element lithium and barium, in groups 1 and 2 respectively, are somewhat similar in properties. However, their properties are very different from the properties of fluorine, the period 2 element in group 17. The two sets of elements placed below the periodic table make up what are called the lanthanide series and the actinide series. These metallic elements fit into the table just after element 57 and 89. They were placed below the table to keep the table from getting too wide. There is a section in the back of your textbook called Elements Handbook, pages 726 through 783, which covers some representative elements in greater detail. You will use the information from the handbook to complete the questions throughout this course. The periodic table is broadly divided into two main sections, metals and nonmetals. As you can see in the periodic table, which is shown in your book on page 21, the metals are at the left and in the center of the table. The nonmetals are toward the right. The elements along the dividing line show characteristics of both metals and nonmetals. Some of the properties of metals may be familiar to you. For example, you can recognize metals by their shininess or metallic luster. Perhaps the most important characteristic property of metals is the ease with which they conduct heat and electricity. Thus, a metal is an element that is a good conductor of heat and electricity. At room temperature, most metals are solids. Most metals also have the property of malleability. That is, they can be hammered or rolled into thin sheets. Metals also tend to be ductile, which means that they can be drawn into fine wire. Metals behave this way because they have high tensile strength, which is the ability to resist breaking when pulled. Although all metals conduct electricity well, metals also have very diverse properties. Mercury is a liquid at room temperature, whereas tungsten has the highest melting point of any element. The metals in group 1 are so soft that they can be cut with a knife, yet others, like chromium, are very hard. Some metals, such as manganese and bismuth, are very brittle, yet others, such as iron and copper, are very malleable and ductile. Most metals have a silvery or grayish-white luster. Two exceptions are gold and copper, which are yellow and reddish-brown respectively. The images on your screen here show examples of metals. Gold, shown in part A, has a relatively low reactivity, which is why it may be found in nature in a relatively pure form. Copper, shown in part B, is used in wiring because it is ductile and is an excellent conductor of electricity. Aluminum, shown in part C, is malleable and can be rolled into foil that is used for wrapping food, for example. Copper has a characteristic reddish color and a metallic luster. It is found naturally in minerals such as chalcopyrite and malachite. Pure copper melts at 1,083 degrees Celsius and boils at 2,567 degrees Celsius. It can be readily drawn into fine wire, pressed into thin sheets, and formed into tubing. Copper conducts electricity with little loss of energy. Copper remains unchanged in pure, dry air at room temperature. When heated, it reacts with oxygen in the air. It also reacts with sulfur and the elements in group 17 of the periodic table. The green coat on a piece of weathered copper comes from the reaction of copper with oxygen, carbon dioxide, and sulfur compounds. Copper is an essential mineral in the human diet. Many nonmetals are gases at room temperature. These include nitrogen, oxygen, fluorine, and chlorine. One nonmetal, bromine, is a liquid. The solid nonmetals include carbon, phosphorus, selenium, sulfur, and iodine. These solids tend to be brittle rather than malleable and ductile. Low conductivity can be used to define nonmetals. A nonmetal is an element that is a poor conductor of heat and electricity. If you look back at the images on the previous slide, you will see that there are fewer nonmetals than metals. Some nonmetals are illustrated on the screen here. A is carbon, B is sulfur, C is phosphorus, and D is iodine. Phosphorus is one of the 5 solid nonmetals. Pure phosphorus is known in 2 common forms. Red phosphorus is a dark red powder that melts at 597 degrees Celsius. White phosphorus is a waxy solid that melts at 44 degrees Celsius. Because it ignites in air, white phosphorus is stored underwater. Phosphorus is too reactive to exist in pure form in nature. It is present in huge quantities in phosphate rock, where it is combined with oxygen and calcium. All living things contain phosphorus. A stair-step line separates the metals from the nonmetals on the periodic table. Several of the elements in the vicinity of this line are often referred to as metalloids. A metalloid is an element that has some characteristics of metals and some characteristics of nonmetals. All metalloids are solids at room temperature. They tend to be less malleable than metals, but not as brittle as nonmetals. Some metalloids, such as antimony, have a somewhat metallic luster. Metalloids tend to be semiconductors of electricity. That is, their ability to conduct electricity is intermediate between that of metals and that of nonmetals. Metalloids are used in semiconducting materials found in desktop computers, handheld calculators, digital watches, televisions, and radios. The elements in group 18 of the periodic table are the noble gases. These elements are generally unreactive. In fact, prior to 1962, no noble gas compounds had been identified. That year, the first noble gas compound, xenon tetrafluoride, was prepared. Their low reactivity sets noble gases apart from the other families of elements. Group 18 elements are gases at room temperature. Neon, argon, krypton, and xenon are all used in lighting. Helium is used in party balloons and weather balloons because it is less dense than air. At this point, you should be able to use a periodic table to name elements given their symbols, use a periodic table to write the symbols of the elements given their names, describe the arrangement of the periodic table, and list the characteristics that distinguish metals, nonmetals, and metalloids.